Good morning, all of you. How are you all? This is Shankar sir. Welcome back to RS Academy. So we are discussing basics of class 10 chemistry CBSE state as well. In last session we have done two basic points. One is elements and symbols, and second one is electronic configuration. I hope you understand. Okay, in this session, let us start third basic point, that is valency, electrons and valency. Get ready, students. Let us start valency, electrons and valency. So, proceeding along with me, basic topic number 3, basic topic number 3, valency, electrons and valency. Valency, electrons and valency. So these are today's basic point. Right. Valency, electrons and valency. What is meant by valency electrons? Valency electrons. Valency electrons. Valency electrons means the number of electrons present in outermost shell of an atom. Outermost of shell of an atom is considered as valency shell, or instead of that we can say the number of electrons present in, write down the number of electrons present in valency shell of an atom. Number of electrons present in valence shell of an atom. The number of electrons present in valency shell of an atom is called valency electrons. So let me give in detail explanation regarding this one. Valency electrons. So you must have know that all the protons and neutrons are located center of the atom, is called nucleus. Negatively charged electrons are revolving around the nucleus in a fixed circular path. Around the nucleus in a fixed circular path. Let me draw this one here. These are shells or orbits. Listen to me. Let us assume atom X. Let it be atom X. It has 4 shells. 1, 2, 3 and 4. 4 shells. The fourth shell will be a valency shell. So valency shell means outermost shell. So valence shell also called outermost shell. Outermost shell. Outermost shell also called ultimate shell. Ultimate shell. So outermost shell is called valence shell. So valence shell also called ultimate shell. That means if the atom has 3 shells, third shell will be a valence shell. If the atom has 2 shells, second shell will be a valence shell. But the given picture, atom has 4 shells, the fourth shell will be a valence shell, also called outermost shell, also considered as ultimate shell. Before the valence shell is called penultimate shell. Let me write here penultimate shell. Before the valence shell is called penultimate shell. Penultimate shell. Before the valence shell is called penultimate shell. So before the penultimate shell is called anti-penultimate shell. Anti-penultimate shell. Anti-penultimate shell. Anti-penultimate shell. So make a note of it. So listen to me. So in this given atom, it has 4 shells, 1, 2, 3 and 4. Fourth shell will be a outermost shell. Outermost shell is considered as valency shell and also called ultimate shell. Before valence shell is called penultimate shell. Before penultimate shell is called anti-penultimate shell. So these are the specified names to call last shell and before that and before that. So please make a note of it. So according to definition, valence electron means number of electrons present in outermost shell of an atom is called valency electrons. Is it clear what is meant by valence electrons? Valence electron means number of electrons present in outermost shell of an atom. Outermost shell of an atom is called valency shell, also called ultimate shell. Is it clear to you? Right. Now, let us have a talk about valency. Valency electrons and valence you are discussing. In that one, first point I have done, that is what is meant by valency electrons. So let us take some example. After that, let us look into what is valency. Listen carefully. To find out valence electrons, we have to know electronic configuration. I have explained electronic configuration in previous video. Please go through that, then you will get how to write electronic configuration for any element. But within 2 minutes, I would like to recall once what is electronic configuration, how to write electronic configuration. Have a look. So electronic configuration means the distribution of electrons in various shells of an atom. To write electronic configuration, we require 3 points. Point number 1, atomic number. Atomic number. Point number 2, list of subsets or capacity of subsets. In case of S, we need to fill 2 electrons. In case of P, 6 electrons. In case of D, 10 electrons. In case of F, 14 electrons. Next, capacity of the subset, order of the subsets. Right? I said S, S, PS, PS, DPS, DPS, FDPS, FDPS, FDPS. So S start with first element 1, 2s, 3s, 4s, 5s, 6s, 7s, 8s. P start with 2 element 2p, 3p, 4p, 5p, 6p, 7p. D started with 3 onwards 3D, 4D, 5D, 6D. F start with 4 onwards 4F, 5F. So in this way we need to arrange the orbitals according to the increasing order of energy. Okay. So first we need to fill the electrons in 1s followed by 2s followed by 2p followed by 3s like that. So these 3 points are basic points required to write electronic configuration. What we have discussed in previous sessions. Please go to that electronic configuration video. So and then you will get clear picture how to write electronic configuration. Right. So these are the required points. Now let us write electronic configuration of one element and let us find out valence electrons of particular element. So let us take silicon. Silicon atomic number 14. So it has 14 electrons. We need to distribute 14 electrons in these orbitals. First we need to fill 1s, s maximum capacity 2 electrons. So followed by 2s, capacity 2 electrons, followed by 2p, 6 electrons, 10 electrons completed, 4 electrons remains. After 2p we need to enter into 3s2, 12 electrons we have done. Next after that S we need to enter into P, that is 3p2. So this is the electronic configuration of silicon. So if you want to find out valence electrons, we have to know electronic configuration. So if you know the electronic configuration, then you will be able to understand how many shells are there in the particular element. If you know the shells in the particular element, then it's very easy to find out which one is a valence shell and how many valence electrons are there in the particular element. Right. Silicon. Silicon electronic configuration 1s2, 2s2, 2p6, 3s2, 3p2. In this one, so 1 means first shell, 2s2p means second shell, 3s3p means third shell. Let me draw the shell representation diagram of silicon. Let us assume the nucleus of silicon. It has three shells. First shell, second shell, and third shell. First shell, second shell, and third shell. First shell, how many electrons? 2 electrons. 1, 2. Second shell, how many electrons? 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Third shell, how many electrons? 4. 1, 2, 3, 4. In case, according to silicon atom, it has 3 shells. Third shell will be a valence shell. How many electrons in third shell? 1, 2, 3, 4. 4. The number of valency electrons in silicon is 4. Number of valence electrons in silicon is 4. Is it clear to you how to find out valence electrons? So, if you want to find out valence electrons, we have to know electronic configuration. Is it clear to you? Okay, right, good. So, now let us take one more element in order to find out how to find out valency electron. In order to understand how to find out valency electrons. Right. Let us take one more element. Listen carefully. Please make a note of it. Iron, let us take. Iron atomic number 26. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So this is the electronic configuration of iron. So how many shells are there in iron? First shell 1. This is the second shell. So these three are belongs to third shell. 3s, 3p, 3d belongs to third shell. So fourth shell. 4 shells are there in the iron. 1, 2, 3, and one more shell we required. It will be a fourth shell. Right? How many electrons in first shell? 2 electrons. Second shell 8 electrons completed. Third shell 12 plus 14 electrons are there. But here how many? So third shell 14 electrons. 6, 12 plus 2, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 electrons. So let us count from this onwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 electrons. Right? Third shell. Second shell, fourth shell, 2 electrons. Number of valence electrons in iron, 2. So valence electron means number of electrons present in valence shell of an atom. Valence shell means outermost shell of an atom. Is it clear how to find out number of valence electrons present in the atom? Right, good. Now, let me write valence electrons of 1 to 20 elements. Please make a note of it. Valence electrons of 1 to 20 elements. Hydrogen, atomic number 1, electronic configuration 1s1. Valence electron 1 because it has only one shell, 1 electron. Helium 1s2, valence electrons 2. Lithium 1s2, 2s1, the last shell, valence electron 1. Beryllium 4, 1s2, 2s2, the last shell, 2 valence electrons. Boron 1s2, 2s2, 2p1. So first shell, second shell. Valence electrons 3. Next, carbon 1s2, 2s2, 2p2. Valence shell, second shell will be valence shell, so 4 valence electrons. Nitrogen 1s2, 2s2, 2p3, 5 valency electrons. Is it clear? Are you following? Right, good. Oxygen 1s2, 2s2, 2p4, valence electron 6. Fluorine 1s2, 2s2, 2p5, valence electron 7. Neon 1s2, 2s2, 2p6, valence electrons 8. So these are the valency electrons of 1 to 10 elements and 11 to 20 try yourself. 11 to 20 try yourself. Okay. So this is what is meant by valency electrons. So valency electrons means the number of electrons present in outermost shell of an atom. Outermost shell is called valency shell. Is it clear? Right. Good. So now let us move on to valency. What is meant by valency? Valency. So valency means combining capacity of an element. So bonding capacity of elements. Some elements give one bond with neighboring, some elements give two bonds with neighboring, some are three, some are four. So that is called valence. Valence means the combining capacity of an element, bonding capacity of an element. But one more definition is there for valency, that is valency means, write down, valency means number of electrons lost or gained or shared by element to get nearest noble gas configuration. This is called valency. Simple definition for valency, that is combining capacity, bonding capacity. Number of bonds are given by the element with neighboring is called valence. But one more in detail definition there for valency. Valency means number of electrons are lost, number of electrons are gained, number of electrons are shared by the element to get nearest noble gas configuration. You must have known that each and every element in the periodic table always try to attain nearest noble gas configuration by the gain or loss or sharing of electrons. Because of noble gases or stable gases, they have no tendency to take a part in chemical combination. So that's why each and every element in the periodic table try to attain nearest noble gas configuration by the loss of electrons, by the gain of electrons or sharing of electrons. So this is the exact definition regarding to valency. Right. So I would like to give generalized formula to find out valency, and please make a note of it. Valency formula: valency of an element equal to valency electrons. Valency electrons. Valency equal to valency electrons. If the element has valency electrons 4 or less than 4, very important. If the element has 4 or less than 4 valency electrons, so the number of valency electrons must be equal to valency. This is the formula number 1. Formula number 2. Valency equal to 8 minus valency electrons. 8 minus valency electrons. If the element has more than 4 valency electrons, more than 4 valence electrons. So these two formulas are generalized formulas. Some exceptions also there. You will get that in higher classes. But I would like to give two formulas in order to find out valency. One is valency means it's equal to valency electrons if the element has 4 or less than 4 valency electrons. So one more formula, valency equals 8 minus valency electrons if the element has more than 4 valency electrons. Is it clear to you? Please make a note of it. Now let us find out valence electrons and valency of 1 to 20 elements. These valencies of elements help to write making chemical formulas in further classes. Okay, right. Valency electrons and valency. So make a tabular form like this: element, electronic configuration, valency electrons and valence. Please make a note like this. Make a tabular form yourself. Right. Element hydrogen. Electronic configuration 1s1. Valency electrons 1. Valency also 1. Because of, according to formula number 1, if the element has valency electrons 1, 4 or less than 4, it must be equal to its valency. Here hydrogen valence electron 1, so valency also 1. Next one, helium. Electronic configuration 1s2, 2 valence electrons, but valence of helium is 0, exception because of helium is a noble gas. So all the noble gases valency is equal to 0. Please remember that. Next one, lithium 1s2, 2s1, it will be a valence shell. So 1 valence electron, valence also 1. Beryllium 1s2, 2s2, second shell will be a valence shell, 2 valence electrons are there, so valency also equal to 2. Next one, boron. Electronic configuration 1s2, 2s2, 2p1. So third shell will be, second shell will be valence shell, 3 valence electrons are there, so valency also equal to 3. Are you following? Is it clear? So element, electronic configuration, valency electrons and valency. Now let us write carbon. Carbon atomic number 6, electronic configuration 1s2, 2s2, 2p2. This one is a valence shell, 4 valency electrons, valency also 4. So after that, nitrogen atomic number 7, electronic configuration 1s2, 2s2, 2p3. Second shell will be valence shell, valency electrons 5. In case of this one, if the element has valence electrons more than 4, we need to use second formula, that is 8 minus valency electrons. The valence will be 3. Next one, oxygen. Atomic number 8, electronic configuration 1s2, 2s2, 2p4. Second shell will be valence shell, 6 electrons are there. If the element has more than 4 valence electrons, then valence will be 8 minus 6, then 2. Oxygen valence is 2. Next one, fluorine, atomic number 9, electronic configuration 1s2, 2s2, 2p5. So second shell will be a valency shell, electrons, valence electron 7, 8 minus 7 equals 1. The valency 1. Neon I will write here. Please make a note of it. Neon, atomic number 10, electronic configuration 1s2, 2s2, 2p6. So second shell will be valence shell and 8 electrons are there. Number of valence electrons 8. The formula 8 minus valence electron, 8 minus 8, 0. That means helium is a noble gas, so the valence will be 0. Next, sodium 11, electronic configuration 1s2, 2s2, 2p6, 3s1. Here, third shell will be valence shell. Only one electron in that. So, valence electrons 1, valency also 1. Next one, magnesium 12, 1s2, 2s2, 2p6, 3s2. The first shell, second shell, third shell will be valency shell. Number of valence electrons 2, the valency also 2. Okay, copy. So now let us move on to next one, aluminum. Aluminum, atomic number 13, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1. Third shell, 3 valence electrons, so valency also 3. Next one, silicon, atomic number 14, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p2. Third shell will be valence shell. Number of valence electrons 4, the valency also 4. Next one, phosphorus, atomic number 15, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p3. Third shell will be a valence shell. Number of valence electrons 5 and valence 8 minus 5, that is 3. Because of, if the element has valence electrons more than 4, then you will get valency 8 minus valency electrons. Is it clear? Right. Next, so sulfur onwards. Sulfur. Atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4. Third shell will be valence shell, 6 electrons are there. Valence 8 minus 6, that is 2. Next one. Chlorine 17, 1s2, 2s2, 2p6, 3s2, 3p5. Third shell will be valence shell. So valence electron 7, the valence 8 minus 7, that is 1. Next one, argon 18, 1s2, 2s2, 2p6, 3s2, 3p6. Third shell will be valence shell. 8 electrons are there. 8 minus 8, 0. Because of argon also considered as noble gas. Next one, 19th, potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Valence electrons 1, valency also 1. Next, last one is calcium. Right, copy these all. Next one is calcium. So calcium atomic number 20, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Fourth shell will be valence shell. So that's a valence electrons 2, valency also 2. So this is a few words regarding to what is meant by valency electrons and valency and related examples. Is it clear to you? Right, good. So please follow these all points and make use of these all points in order to write chemical formulas. Okay, so this is the basic point 3. Thank you. Please subscribe the channel and share and like videos. Thank you, my dears. Have a nice day.